Hey guys, it's me again, Barry with Barry's 8-Track and Classic Car Radio Repair. And tonight's subject is I've had a lot of customers lately. They're pretty dead set on keeping their radios original when they send them in for repair. I'd really rather have it repaired to original stock. I don't want a conversion, even though the external appearance of the unit doesn't change. A lot of customers, and I can go along with some of that too. Would just rather keep everything original like the rest of the car, and so it's become necessary to kind of explain and prove why that's not always possible. It's becoming less and less possible as more time goes by, understandably. For one thing, a lot of the old time radio experts who are used to doing things that old fashioned way have passed on. Quite regrettably, one of my best friends in the business has recently passed on. And, you know, uh, Radios that were made for a society that ran at 10 miles an hour um, at that time could no longer be used to repair radios for a society that now moves at 1,000 miles per hour. There just isn't time amidst all the pressures of everyone's lives, to do things the slow, meticulous way all the time. And in some cases, even if we wanted to do it, it's not possible. And so that brings me to the subject of some of the older Delco radio designs. I will begin by saying I'm a huge fan of Delco circuit designs. I think they designed some really good circuitry. It was long lasting. The problem was some of the parts that they came up with. They just don't hold up that well, and they're no longer available. In fact, haven't been available for decades. But just as an example, here are a couple of preamp chips. I can't even really call them chips, and we'll get into the design of we'll talk about integrated circuits too. But these are some very early design integrated circuits. This little large white rectangle there, and then there's the one for the other side. These are preamp and pre-driver chips for the audio circuits after the signal from the 8-track and or the radio, go through these preamps, and they're sent on to the power amplifier. And now we're going to do a little bit of discussion about integrated circuits so that you can more fully understand what I'm talking about here. Now, pretty much everyone knows what an integrated circuit is. It's also called an IC or a chip. I call them chips because I'm a one-syllable kind of guy. The more one-syllable words you can use, the more efficiently you can communicate. So I like things that are one-syllable, so I call them chips. And here's one. Here's one chip, and you can barely see it, and there's a reason for it. They're supposed to be tiny and small. And now this is a more common, and at this point I'm going to go ahead and start using this camera to illustrate my point. The camera that's on me right now, you'll have to excuse me while I get up and redo the focus and zoom and all that so you can see what I'm doing here. But it's the easiest way to do it at the moment. So this is a DM48 Delco chip, as you can see. It was put out by GM. We're not sure who did the actual manufacturing, but it's a Delco DM48 preamp chip. Now I'll show you that smaller chip that I showed you just a moment ago. Here's that one, and this is one of the earliest. This is also one of the earliest chips. It's a 741. It was the first op amp. They call it an op amp, it's short for operational amplifier. It was the first op amp to be widely used in electronics a lot by experimenters. It made its way into a lot of consumer equipment too, but it was quickly outmoded by stuff that could perform faster in a smaller space, and you know how that stuff goes. But this is a chip. This is called a dual inline. It's called a DIP, dual inline package. As you can see, this is an 8-pin DIP chip. It's a 741, and so. Now, one thing you'll notice about this chip is that it's sealed. It's completely sealed. See, there's no way air can get inside there. It's airtight. It's protected against moisture, oxidation, rust, corrosion. It protects it from its harsh environment. Now, let's take a look at this early design Delco chip, and let's look inside it. And holy cow! For one thing, it wasn't sealed. These are not sealed. They're just have a little tab that holds that cover in place. You break that tab off, and this comes right apart. And you can see that for the last 40 years, the parts of this integrated circuit have been absorbing just whatever's in the air. It's covered in gunk, and there's no coating of any kind on this that I could see. Now, when I worked in avionics, they always sprayed what they called conformal coating over all their boards, which sealed them against rust in the harsh environments. Because a lot of times airplanes fly over salt water, and that's a very corrosive environment for electronics to fly through. So, they call it humiseal is the stuff that I use to spray these boards with. But now there's no sealing that I can see of any kind on this. The surface is perfectly matte, and you can even see, if you look very closely, you can even see those little gold things, those two little gold colored things. You can see there's tiny, tiny wires coming off of those, and they're tacked on to a substrate that definitely would not take solder. So you got these little bitty tiny wires, and that's how I know there's no coating, because you can move these wires. They're actually thinner than a human hair, but so the basic gist of what I'm saying here is. These are basically the equivalent of resistors and capacitors. They are resistors and capacitors. This device has 3 connections, so it's obviously a transistor. But in an actual transistor, the elements are sealed way inside the sealed plastic package, and the actual element in a transistor that does the work is just about the size of a pinhead, if even that. And so here you've got this huge transistor here with its elements exposed to the elements. Now transistors are some pretty sensitive devices. It's a semiconductor. Now let me refocus my camera so I can sit down and talk to you for a moment here. Okay, how's that? That's probably good enough. A semiconductor is a really, I guess, picky, selective type of device. Now, whereas a resistor can be a little chunk of carbon that has a certain resistance, and it can be guaranteed, to be 10 ohms, whether the temperature is 10 degrees or 100 degrees, or, whether it's humid or dry or this or that. Transistors are a little bit more picky about that. In fact, a transistor, yes, it's made of silicon and germanium. Germanium was the older type. Now they're made of silicon, but they also need an impurity to work. Semiconductor cannot work without an impurity. That impurity is usually something like gallium arsenide, a form of arsenic. So a transistor depends on some pretty precarious conditions to be able to operate within its parameters. And you get a transistor like this that wasn't even really miniaturized. I mean, a normal transistor is about the same size as this thing. You get the kind of transistor like this with its elements exposed. I mean, with its elements, collector, base, and emitter, exposed to nature's elements. It's just not going to last. There's no way that a sensitive device like a semiconductor can survive in a real world environment. And in fact, during the mid 60s, when integrated circuits, which are basically entire circuits within a part, instead of making 42 connections, you can get one part and make 8 connections, and that connects the whole circuit to your surrounding circuitry. During the mid 60s, when ICs were first being developed, the largest consumer of integrated circuits in the world was NASA. During the Apollo missions, they were the consumer of 50% of all chips produced in the world at that time. So they were like an early pioneer in the development and execution of integrated circuit styles and capabilities. Now, their testing methods, because these are supposed to be sealed against the elements, and out in space there is no oxygen, so there's no danger of oxidation, there's no danger of rust, there's no moisture in space, but now there is a lot of temperature extreme. A chip can experience anything on a spacecraft that's exposed anywhere close to its outer shell can be exposed to direct sunlight, and then the minus 400 degree vacuum of anything that's in shadow. That's not anything that's blocked by the sun is extremely cold in space. Anything exposed to the sun is extremely hot. So that's why spacecraft have to do a barbecue roll as they're going through space to keep that heat evenly distributed. It rolls at about 1 revolution per minute, I think, just so that one side is not always exposed to the sun and the other side is not always exposed to the frigid of the other side. So anyway, what I'm leading up to here is that their testing methods for integrated circuits when they came in was to envelop them in a under a pressurized environment of freon, basically refrigerant, the same stuff you use in your air conditioners, the same stuff that's in freeze spray that technicians use to freeze a component to see if that'll fix the problem. Um, they basically pump the gas into these things, and then after a period of absorption, they would weigh the components, and if they were like a microgram heavier than they knew that some of that gas had gotten into the things, they would reject the entire lot of 5,000. If one was bad, they would reject the entire lot of 5,000. For understandable reasons, it's the first time we're trying to put men, a quarter of a million miles away, land on a distant planet. So yeah, we need our stuff to be reliable. I can definitely understand that. Now, needless to say, a car radio is not, is not under that kind of pressure. Yet it is subject to the elements of the earth. It's subject to moisture, grease, dust, different atmospheric conditions, humidity, dryness, stuff like that. So chips like this just get a beating. And what I think, the reason that I started looking at these little weird white chips in the first place is because so many of them fail. Out of about half the Delco radios I get in that have these chips, I'd say a good 30 to 40% of them have at least one bad chip in here. I don't think it was the circuit design. I think it's that the parts themselves got contaminated by the surrounding environment, because Delco circuit designs are typically very solid and reliable. So that leads me to believe that this is a result of just inferior quality, not really knowing at the time what the state of the art would be and what it would require as far as long-term reliability. So you got to, my hat's off to Delco for their circuit designs and for coming up with this really cool idea. But it's hardly a miniaturization, which was one of the big purposes of integrated circuits, was miniaturization. In fact, like in a typical computer, if you can put a microscope on the inside of the processor chip, it would literally look like a street level map of 10 Londons within a quarter-inch space. That is exactly, that's a very accurate description of what the circuitry in a large processor chip would look like. I mean, this stuff is just, millions of transistors, which on this chip is almost a quarter-inch wide. A computer processor chip contains literally millions of transistors, just so micro-miniaturized. So that kind of makes this sort of a joke, as far as the miniaturization factor. And then another problem that this type of design can cause, and even if they are still working, this is a preamp. It's a preamplifier, so it's working with some pretty small signal levels, meaning it has to have really high gain. So having that much gain inside of a device that sticks up this high amid surrounding circuitry, well, that acts not only as an antenna for interference from the other stuff, it can also radiate its own interference into the radio. It's just it was, I guess, the best they could do back then. It was a great innovation at the time, but it's proven in the real world of the aftermarket repair business, it's a really bad thing, because these cannot be replaced. There's no way to replace these. You can't build something to replace them. You don't know what's inside these things. I mean, resistors look just like capacitors on this thing. A transistor might be two coils hooked back. You just don't know. But at any rate, a preamp is basically an input and output, a power and ground. That only takes 4 pins. This has 8 pins, so there would be the question of how does this interact with the surrounding circuitry in the radio itself. So nobody's going to sit down and try to duplicate these things. It's just not possible. Okay, it's possible, but nobody's going to take the time to do it. No company is ever going to try to remanufacture these, because you'd have to sell 5,000 to recoup your expenses. Nobody's going to buy 5,000 of these things to fix a few hundred radios that are out there that can easily be converted with modern Aurora products, which work a heck of a lot better anyway. So anyway, that's just one illustration of the points that I'm making. Other radios have different problems that prevent them from being repaired to original stock. Fords are pretty well known for their output transformers. Fords and Chryslers, they're kind of known for bad output transformers. Some are great designs. The chrome-faced, the black-face Chrysler AMA tracks are excellent designs. You can almost always fix fix everything on those. Uh, but now anything that has these integrated circuits that were only made for a short time, you're just not going to find a way to replace them. And because they do have a high failure rate, they're not something that I'm going to dig out of a parts radio to install into a customer's unit and say, thanks for the $400. Here's your piece of junk with another 50-year-old part in it. That's just not the way I operate. When a radio has a part like this that's bad, and even a radio that has a part like this that's good, it's going to go bad. It's inevitable. There's no way around it. You can't deny the elements of nature and the effect that it has on certain certain materials, and these just are not robust type chips to be lasting yet another decade in somebody's car that's out in the hot and cold and different environments. And then now that brings another point up is back in the 80s, back in the late 70s and 80s and through I guess maybe the mid 90s, you didn't have to have the original manufacturer part because you had cool companies like NTE. Now this is the later substitution company. Before NTE was Philips with their ECG line, and instead of having to figure out where you're going to get 100,000 different types of transistors to be able to fix anything you might run into, you had these companies who manufactured replacements, and 20 different transistors can have similar enough parameters that they can be substituted for each other. So long story short, this company, you could replace 100,000 components with maybe 10,000, and they'd work just fine. If you had like say an early style output transistor that's no longer available, one that has similar parameters and can handle more current could replace it. As long as the extra current carrying capability didn't make it so robust that it couldn't handle, high frequencies and stuff like that. But so yeah, in the 70s and 80s, these were our gods. I mean, if TV, VCR, whatever it was, if we needed a part, we never had, you never really had to worry about, God, is RC going to sell me this part because I'm just a little guy working out of his kitchen. You had companies like ECG and NTE, and thankfully, when ECG, I don't know a whole lot about these companies. ECG apparently, went out of business at some point, and NTE kind of grew up in the business at some point. Maybe it was a simultaneous thing, but thankfully NTE uses the same numbers that ECG used. If you needed an ECG 189 to fix something, you could use an NTE 189 and you'd know that it was the right part. You didn't have to worry about it. In fact, I still think in terms of ECG because I'm an old fart from 1973. That was when I started working on electronic stuff for money, and so I grew up in this environment. It's like, yeah, this is where you go. And so to see both these companies pretty much, there's simply not that much market for these types of semiconductors anymore. Nobody has VCR repair shops anymore. Nobody, DVD players aren't even worth trying to fix. You can get a new one for $30, and so there's just not enough market for these types of parts anymore for companies to continue manufacturing, bearing the expense of manufacturer and marketing and distributing. So they've come out with new solutions, which is what this whole thing works up to, is that a radio of this nature, even if I can repair it to original stock and have it working great, it's very likely to fail again in the next few years, and then you're going to have to send it back to me, and I'll have to say, well, you chose repair to stock the first time around, and now I have to tear the thing completely apart and do a complete rebuild on a conversion, so I really can't give you much of a discount. I recommend doing the conversion first off, one and done, get it out, and you never have to worry about it again. So that's this video is made to support that point. Apparently there's a lot of older guys who just think, well, he's just trying to make more money, or he's trying to just bump me up the price here. Well, I got news for you guys. A conversion carries a much lower profit margin than repair to original stock. I would rather repair to original stock. It's more money in my pocket. Conversions, I got to lay out a huge chunk of cash for parts, and I don't charge the customer nearly as much as I pay for those parts. So when I say we got to convert it, I'm not trying to screw you out of money and make more money. I'd rather do a stock repair because I lose money. I don't make as much money on. I don't lose money, but I don't make as much money on conversion. So, you know, just try to keep reality in mind, guys. This stuff was made when every single telephone was tied to a wire, you know, and we just had to watch whatever they had on TV in black and white at the time. We had no choice, and a lot of TVs didn't even have remotes. Some TVs still took, 30 seconds for the sound and picture to come on. So it's just unrealistic to expect this type of stuff to still be repairable using the techniques and parts that were available then. The parts are no longer available. The techniques are no longer realistic. You know, it was Leave It to Beaver ideals back then. Nobody really had a lot of cares. Everybody moved at a nice, normal pace. Nowadays, everybody's trying to do 10,000 things at once, and they have 10,000 devices in their hand. So it's just not realistic to expect, you know, people of our age and a person with my skills and talents to go back to plodding along at 10 miles an hour, dragging out scopes and meters and tracing down things using schematics, half the time to find out that it's a part we can't get. We just don't do that anymore. And so I'll close with that. I hope that I've come across as being, fairly polite about this. But it's something that is just, I have to be polite but firm. It's just, in some cases, it's just not going to happen no matter how bad you want it. Even if you're willing to send me a parts unit, I'm not going to put that old junk into a unit that I'm charging money to fix. It's just that simple. That's not the kind of shop that I run, and I hope that not many shops run like that. So, with that being stated, I'm Barry with Barry's 8-Track and Classic Car Radio Repair, proving why some radios simply cannot be repaired to original stock anymore. And even if they are, it's not advisable because I just, if I'm recommending convert it, it's best to convert it because if you come back to me 6 months later and say, it's out again and you need to fix it, I'm going to say, well, now we got to do a conversion, and I'm sorry, but I can't give you much of a discount because you're asking me to do at least 12 hours worth of work here. So that's the harsh reality of the whole thing. So thanks much for watching and listening, and we'll see you next time.